Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today we will be talking about friction. We will add another force into consideration because there is a lot of mechanical problems with friction. So we start with a very simple case. The body mass is given. As soon as mass is given, we immediately draw a force, gravity, mg, body on the surface. The second force is normal reaction. Nothing new here. So we have normal reaction and mg. And so far it was everything that we were looking for. But now let's add the force that tries to pull the body to the side. And what of course will happen, there would be F friction. F friction. F friction will appear from nowhere just to compensate for this external force F. And so actually your body, if I draw it here, it interacts with the surface through normal reaction, and it also interacts through the friction. Right? Normal reaction is because mg, gravity, pushes the body to the surface, and surface reacts. So surface reacts in the opposite direction, and friction, because I'm trying to push the body to the side, the friction goes opposite way. If I apply this force F to this side, then the friction will be applied in the opposite direction. So it tries to balance, the friction tries to balance this external force. So N is normal reaction, tries to balance gravity, and friction tries to balance external force. Of course, the total force that the surface is acting is the sum of those two vectors. So this is F total. But nobody will ever be looking on this F total unless they specifically ask you about this. They always will be looking for F friction, most of the time. But of course, we should understand that total force is this. This is a vector. This component of this vector, projection in vertical direction y, is normal reaction, and projection that goes parallel to the surface is called friction. So friction is always parallel to the surface, and normal reaction is always in perpendicular way. And the relation between friction, this force and this force, does exist, but it's very weird and very strange at first, but nothing complicated, if you will see. So if I apply a small force, the friction would be enough to keep it static. It is static friction. And this friction would be just so this F equals F friction. So if body is in static position, and this is y and this is x, I can say that acceleration equals 0. That means static. Those are synonyms. Static and A equals 0 are synonyms. And if this is so, I can say the sum of all forces equal ma, and I can say the sum of all forces mg plus n, and those are all vectors of course, plus F, this force, and plus F friction equal ma equals 0. But because it's static, critical word static means A equals 0. Okay, very good. And so I can put on x, mg, projection mg on this x is 0, N is 0 because those are vertical and X is horizontal. F goes to the right. F friction goes to the left, hence I put the minus sign here, equals 0. And along y-axis we draw it many times. mg minus because it's going down against y. N is positive because it's going up same direction as y. And here would be 0 and 0 because those two forces has no projection on y. And it's equal 0 of course because nothing is moving in this direction at all. And so I can have from the first equation F friction equal F, and from the second N equal Mg. And this means static. Everything is static. And this would be, static would be, we know that if we will push something a little, nothing will happen, it will be still at rest. But if we pull a little bit stronger, we will have a movement, and it's called kinetic friction. Kinetic friction, and this kinetic friction is when A is greater than 0. So, what's the difference between this? The difference is A really exists. This is all still valid because second law of motion doesn't depend on those little things, whether it's moving or not. The sum of all forces is equal ma mass on acceleration. But here would be ma. And of course, if I push with F, A goes here. And of course, in all those solutions, we have to verify later on that A greater than 0. We cannot receive negative result because if we push this way, we can go only that way. It's kind of like tension, the force of tension has to be positive. Same here, we have to verify in the end or validate that our result leads to positive A. And we will have problems, a complex one problem later on, when this would be like a tricky case. But right now it's very simple. All we have ma and vector, and here projection, it would be ma, right? And it is, I am looking now for kinetic case. Kinetic friction, not static, because A is greater than 0. It's real sliding one body on another, no rest. And this would be the same, and so let's check. F friction equal F minus ma. If I write the same F friction there, F there, minus ma, and mg, and look what I have here. I have F friction, nobody knows what it is. I have n, is also unknown. Of course, we solve it, so this is one equation we can say, and then we know. But if we look on two equations, n is unknown, friction is unknown, and A is unknown. And we have only two equations, when in fact we need three to solve it. But hopefully, thankfully, gratefully, when we have kinetic case, we can always say that F friction equal mu multiplied by n. So this is a strange way about the friction in kinetic case. When we're moving, when we're sliding, this force is a portion of this n. They always relate. And mu is a coefficient that is defined by the surfaces. If this is, for instance, ice, and this is metal, it's one mu. It's metal over metal, it's another mu. It's steel over copper, it's another. Wood against metal, it's another mu. You obtain this mu through the experiment, it's in the table, and typically it's given to you in your problem. So if this is a case, and I have this, I can wipe it out, and I have n equal mg, and F friction equal mu n. So I have mu, I put it here, instead of F friction I put mu N, and instead of N I put mg, right? Equal F minus ma, and I can immediately say that ma equal ma to this side, F here, minus mu mg. And so this is what I know here. ma equal F minus mu mg. And this is my solution. And this is my solution. So now let's go back to this particular problem. And I wipe this out. And I go to the numbers that they give to us. And the numbers that they give to us is m equal 1 kilogram, kg, right? Mu, let's say, equals 0.3. And this mu is called friction coefficient, or coefficient of friction. So it's typical 0.3, not big, not small. And they want us to solve in two cases, 2 Newton and 4 Newton. And so we have always to consider this friction and find the friction kinetic friction first, because when we grow this F, if friction grows, so it balances this, and this equals this, but up to the limit. And the limit is this. As soon as this F friction reaches this value, it doesn't grow anymore. It doesn't grow anymore, it stays the same, it is mu multiplied by n. But in this particular case, we know n equal mg. We know mg, so n equal 10 newtons. We know that this critical friction, special friction, I don't know, let's call it F critical. It's equal mu multiplied by n, and if we put the number 0.3 multiplied by 10, it's 3 newtons. So basically this is a critical situation. If we apply 2 newtons, it's less than 3, and F friction equal F and equal 2 newtons, and everything can balance, and A equals 0. And this is static situation. But if we would apply 4 newtons, then F friction, maximum friction that it can get is 3 newton. But we're applying way more. We're applying way more, that means we're in this situation, and this is kinetic situation. And in this situation, F friction is mu n, and we already know that it is 3 newton, and it's maximum it can get. And from this equation, then we get ma equal F minus mu mg, and we can find acceleration. And acceleration will be F minus mu mg divided over m. And if we will plug the numbers, F is 4, so let's draw it here. A equal 4 minus mu 0.3, mg is 10, 9.8, but I write 10, who cares, divided over m is 1. So we have 4 minus 3 over 1, it would be 1 meter per second squared. So this solution has this problem has two solutions. For if force is only 2 newton, then everything is in balance, everything is in rest. F friction doesn't reach its maximum value, and everything is balanced, this equal to this, and no acceleration. If force is equal 4 newton, then yes, this is system slides to the right, because this is F 4 newton and friction is the maximum. In this situation is only 3 newtons, so 4 newtons naturally overcomes 3 newtons, and the system slides there with acceleration A equal 1. and we will have more on this, obviously. So subscribe and like and bell and have a question. Thank you.